Good afternoon, everybody. Welcome to another exciting afternoon of Organic Chemistry, Chem 170, with your host, me, Dr. White. For those of you who are going to watch this video, hi. For those of you who are here live, hi. I'm in a good mood. This weekend, I did battle Saturday morning with Mother Nature, mowed my lawn, did a lot of yard work. I don't know if you were out Saturday morning, but it was beautiful. In the summer, I started early. I started about 7 o'clock, 7:30. I was done by 9:30. I was sitting out on my deck for a while. Oh, it was so nice with the wind and everything, the low humidity then and low temperature. All right, some important public announcements from the management, me. First of all, if you've been watching TV or reading the newspaper, you know the new Delta variant, not no new, but Delta variant of COVID-19 is going around this country, and it's quite nasty. If you haven't gotten your vaccines, both of them, and I got mine, my second one was the middle of April. It took a while for me to get appointments, but then I was able to get it. If you haven't gotten your vaccines, get it. It's for your own protection. All right. Another important announcement. On Thursday after class, I will be giving test number one. Test number one, you'll be able to download, excuse me, sometime Wednesday afternoon as a password protected PDF file. I definitely download it before. You can wait, but I would. That's why I'm doing it early, having it ready. And then right after, about 5-10 minutes after the end of class on Thursday, I will send out a password to you via email, your student email, that allows you to open the test number one PDF file and take it. Now, you will have until Friday morning, 10 a.m., to take it, scan it, or to use your cell phone to make a PDF file. If you want to use Word, you can upload it as a Word document too, but it's in a PDF already. But anyways, and upload it to D2L, the assignment area. Did I say Blackboard earlier? I might have. Anyways, D2L. Now, in face-to-face, I usually give students 50 minutes, take an hour or so. Do not cheat. I know if you'll cheat if you go on the internet, you talk to people, or you look at your notes. I will know. I have secret things in my test. Having been teaching Zoom now, I know how to do things like that and catch students. So please don't cheat. I will do what's in my syllabus. All right. Now, what's the best way to study for test number one? Hopefully you've been doing the practice problems. That will help you. Also on Tuesday, tomorrow, I will do my world famous review for the next test. In this case, test number one. Students tell me that helps them. Guess what? I do it. And that will be the beginning of lecture tomorrow. Don't forget, if you have questions, I have my office hours on Monday, Wednesday from 6 to 7:15. Now, I do want to ask you a question. I'll probably put it out maybe tomorrow. I have time as an email. I didn't have time this weekend. I was quite busy. But if you think a better time for me to have my office hours, let me know. Now, I should warn you, not warn you, tell you, on Monday, Tuesday, Wednesday, Thursday, essentially I'm teaching from 9 in the morning till 4. Because I teach another class before this one at College of DuPage, and I come here and teach this one. So anytime on Monday, Tuesday, Wednesday, or Thursday, before 9 and after 4, where you would think would be a better time for office hours, let me know and I'll see if we can swing it. Because I'm here to help you. And if my office hours should be at a different time, let me know. Friday, Saturday, and Sunday, I'm busy. So I like a couple of days to myself. I'm selfish that way. All right, let's see. Test 4 Thursday, test 1 Thursday, review. And now let's get back to work. we're in a good place. I looked at the schedule where we are, and we're not behind, which is always a concern of mine where I have to rush. We're actually a little ahead. So today is a lab day. What we'll do is, first of all, I'll do about 50 minutes, go up till about 1:50. We'll have a break, then we'll do the lab. It's a quick lab today, and it's a fun lab. Don't forget to bring your nose to the lab. All right, let's get to work. Now, on last Thursday, we were talking about ethers. What are ethers? Ethers are, oops, hold on, I got to turn on my tablet. And it's on. Here we have an ether. And how do you make an ether? The Williamson ether synthesis. And an ether is an alkoxide, RO minus Na plus, plus an alkyl halide. And I don't have here, but I should have. X can be chlorine, bromine, or iodine. Remember, this stuff, like alcohols, will not be on test number 1. It'll be on test number 2. I've already talked about test number 1 will be hydrocarbons, alkanes, cycloalkanes, alkenes, alkynes, and aromatic compounds, which means double bond, triple bond, and benzene rings. And we've already gone through all the problem sets for that. All right, so this is a Williamson ether synthesis, alkoxide plus an alkyl halide. Remember, the carbon with the halogen in R prime will be the carbon in R prime in the ether that the oxygen is bonded to. I'll say that again. Remember, the carbon in R prime X, the alkyl halide, will be the carbon in R prime that the oxygen is bonded to. What happens is, did I tell you organic chemists are violent? We are. This attacks that carbon and bonds to it. And we've did a couple, but let's do one more. I'll let you do one more. And the question would be 3 points, give the organic product or products for the following. And when you're done, give me a thumbs up. In case you haven't memorized it, let me help you out. All right, if you're done, give me a thumbs up. Going once. All right, it looks like everybody's done. Let's take a look at this. When you look at a molecule, look for what's different. What's not a carbon, what's not a hydrogen, what's not a carbon-carbon single bond to get your attention like that. And oh, look, oxygen, negative charge, sodium cation, plus charge, and carbons, alkoxide. Carbon, 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 ooh, carbon with a halogen, alkyl halide. And what you get is an ether. You don't have to put this down, but I will, and you'll see why in a second. What's the salt? What's our methyl group? What's our prime? These 4 carbons. Notice the halogen is on the second carbon. So I have my R group, prime group, and it's going to be attached to oxygen. What's my R? Methyl. And you know there are 4 bonds to carbon. And that's what you get, that ether. Now you could have written it other ways too. Here's another way you could have written it. And there you go. Ooh, Dr. White forgot to mention something, but first, that's how you do this problem. I forgot to mention, don't forget, I sent it out in an email. You should be looking at your student email because I'm sending out email updates. The lab we did last Thursday, electrophilic aromatic substitution reactions, is due today. And let me give you a quick hint. Don't forget, there are only 2 types of directors. One is called orthopara, the other is called meta. And I also taught you last week that sometimes if the directing group is very big and you have an orthopara director, it blocks the ortho position and you only get para, but it's still called an orthopara director. Hint. All right, now on test 2, I will have up to 3 or 4 synthesis problems. Not a lot, but let's look at one right here. Again, this is test 2 material, but in the summer we get a little ahead before we get the test, but this gives you plenty of time to study and practice. And the question is, how do you make this compound? What 2 chemicals do react together to make this molecule? So we look at this and say, what's different? Oxygen. Oh, I've got carbons here, R, carbons here, R prime, and look, sodium halide, where X can be chlorine, bromine, or iodine. In this case, X is iodine. And how do you make that? The Williamson ether synthesis. Alkoxide plus an alkyl halide, and that's what you get. I feel a sneeze trying to sneak out. I think I stifled it. Hold on. Oh, it's one of those I don't want to come out sneezes. But anyways, if I look at this, I can say, I'm going to call this R. I'm going to call this R prime. If that's the case, what you would have would be this plus my R prime is ethyl, and my halogen is iodine. And you'd be all happy and correct. But wait, I could say this is R prime and this is R. If that were the case, my alkoxide would be this molecule. And my alkyl halide, R prime is methyl, and the halogen is still iodine. Now let's call this A and B. And the question is, which is correct, A or B? And the answer is they both are. because both of those would give the same product. And that happens in a lot of times in organic chemistry. There's more than one way you can set up a reaction or mix things together to make the same compound. Now, one of the things Dr. White knows that most people don't, especially even the other faculty members at COD, and even where I teach at ECC and also at COD, I think at COD 1 might, but I'm not sure. I've worked heavily in industry. And one of the things I had to learn was it's called cost accounting. How much does something cost? And because I've had many decades experience, I can look at A and B and say, B will be less expensive for the raw materials than A. And therefore, if I want to maximize my profit, I would use B. However, you don't know this, and I don't expect you to know this. So what's the right answer on a test? Both. Either one will work. However, Dr. White knows cost accounting. In fact, one of my biggest regrets from undergrad and grad school, because I didn't know any different, when I was in grad school, I already knew I wanted to go into industry, which I did for many decades working in this chemical industry. But when I got to be a senior manager, I went into a meeting with the vice president and other senior members of the company. They started talking a language I didn't know. What's gross margin? What's EBITDA? And things like that. And guess what I had to do? I called up an accountant friend of my brother-in-law's and said, can you recommend a good introductory accounting book? He called and said, come on over, I got one, I'll lend you. And guess what? I had to teach myself accounting, and I did. So that's something you don't have to know. But like I said, my biggest regret when I was an undergrad, I wish I had taken accounting, either that or in grad school, taken an intro accounting 101 type thing. But being a PhD, one of the things you learn to do is teach yourself new stuff, and I did. So I better let you try one. And one thing I'll do, which my instructor, when I took organic chemistry, that was for chem majors, on a test for synthesis, I'll show you what things you have to include. In that case, 2 question marks. What 2 compounds do you have to react to make that molecule? Have fun. If you came in late, check out the video or ask me afterward about some of the announcements. And as I know, life happens. And when you're done, give me a thumbs up, but I'm going to wait a second or two because this is a challenging one. Maybe not. I hope you're all telling your friends how much fun organic chemistry is. But I'm biased, I'm an organic chemist. I see 2 people done. Anybody else done? Hold on. Give me a thumbs up when you're done. Looks like everybody's done. So I better get to work. All right. Excuse me. I think I got a feather and a frog in my throat. Ribbit. Anyways, how do you proceed? Well, you look at the product and say what's different, what's not carbon, what's not hydrogen, What's not a carbon-carbon single bond? Ooh, oxygen. Carbons on this side, I'll call R. Carbons on this side, I'll call R prime. And then, ooh, salt, sodium halide. And X can be chlorine, in this case it's bromine, or iodine. And this is an ether. And how do you make an ether? You react an alkoxide plus an alkyl halide. And the carbon that has the halogen is the carbon that has the oxygen in R prime. And the carbon with the oxygen in R is the carbon with the oxygen in R there. So let's get to work. I'm going to call this R and this R prime. If that's the case, that's my alkoxide. My alkyl halide, the carbon with the oxygen, is the carbon with the halogen here. 3 carbons, you break carbon-carbon single bonds? No. And what's the halogen? Bromine. I know there are 4 bonds to carbon, so I can put in my hydrogens. And that would be one thing, but no. What if I say, I'm going to call this R prime and this R? And you can. Well, in that case, this is R. The carbon with the oxygen is the carbon with the oxygen here still. So it's the end one. And then my R prime is 2 carbons. And my halogen is bromine. And either way, you will make that product. Now, which is cheaper? Well, let's not get into it, but I believe the top one is in blue. And that's how you do ethers. Remember, ethers are very flammable liquids, lower molecular weight, and they're used a lot as solvents in the chemical industry. I've used ethers in my research when I was in grad school, diethyl ether and cyclic ether called tetrahydrofuran. Boy, they use a lot of that stuff. All right, any questions on ethers before I move on? And guess what time it is? It's new functional group time. I get to talk about an exciting new functional group, and that's called an epoxide. How many of you have ever heard of epoxy coating? And epoxy coatings use epoxides. But we're going to keep it simple. What is an epoxide? It's a 3-membered ring where one of the members is oxygen. So I have one, oh, come on, let's go to black. I have 1, 2, 3-membered ring. And this is called an epoxide. Now, at first glance, you might say, well, isn't this an ether, but a very small cyclic ether? Carbon here, oxygen, carbon. Isn't that an ether? And the answer is no. Epoxides have quite different, dramatically different chemistry than ethers. Ethers are pretty inert. Epoxides are, whoa, really reactive. Now, I better warning, I've worked heavily with epoxides. So if I'm having way too much fun, well, I am. And I'm going to try and be good, and I'll talk about that, how I'm going to do that in a second. So this is an ether. Now, on this carbon, since there's 4 bonds, there's 2, there's other stuff. I'm going to stick to the simplest epoxide. And I don't have a slide for it, so I better do that. Ethers are by IUPAC are called oxiranes, but I'm not going to even teach you the IUPAC or the common, other than the simplest epoxide is called ethylene oxide, the common name. I'll never ask you on a test, what is ethylene oxide? But I'll use that terminology. Now, I've worked heavily with ethylene oxide, another ether called propylene oxide, which I won't mention, do chemistry with. We'll just stick to ethylene oxide. And ethylene oxide at room temperature, atmospheric pressure, is a gas. Under pressure, you can liquefy it, and it's dangerous stuff. Ethylene oxide is very dangerous. If you get oxygen in it under the wrong conditions, and it doesn't take that much to be wrong, it explodes quite violently. And when I got into industry, and the first time I had to run an ethylene oxide reaction, I was a little nervous, but certain parts of organic chemistry separate those who should be doing research and those who shouldn't. And, I overcame that. Getting nervous, but I was always very careful. Now, one thing, ethylene oxide is extremely explosive. And the one company I worked at their storage tanks in, not McCook, Morris, Illinois, had about 500,000 to 1 million pounds of ethylene oxide. Now, another company I worked for, it was in Gurnee, a couple of miles northeast of Great America. We had a research center in Gurnee and also a plant right next to the research center for this company. And this was called PPG Mazer Company. They since sold it to someone else, but PPG owned it. And one afternoon, Friday afternoon, usually Friday afternoons, a bunch of us in this one research group, half hour before we left, we'd sit around and just shoot the breeze, talk about things, what's going right, this thing. And one afternoon, Friday afternoon, someone raised the interesting question: if our 1 million pounds of ethylene oxide blew up, A, would we survive? And B, what would we do to Great America a couple of miles away? And the consensus was if those tanks blew up, we'd be dead like that. And if it blew up, it wouldn't kill anybody at Great America, but it might shake them up on the shock wave. Interesting things to think about when you're working in a chemical plant or near very hazardous chemicals. After a while, you just realize karma. If it's going to happen, it's happened, but no, it's very safe to use. Now, ethylene oxide, and Dr. White's going to try and be very good, because if you're working with ethylene oxide in the chemical industry, we just call it EO. That's slang, and I'm going to try and be good, not use slang to say ethylene oxide is very reactive. It's strained. This ring right here doesn't want to be that pulled together in 3 atoms, 2 carbons and oxygen. It's sort of like you're all tied up in a knot and you want to get loose and spread out. So this is very reactive. Now, the next slide, this will never be on a test. However, ethylene oxide and water, what happens is to relieve the strain in the ring, this bond or this one, the same, pops open. And water, think of HOH. The H will go to the oxygen and the hydroxyl group will go to this carbon. And it opens it up to, in this case, ethylene glycol, which we talked about. and switches off for the slide. And this is why, really why, you never want to run a reaction with ethylene oxide with water present, because the ethylene oxide is not cheap. It's not super expensive, but it's got a price to it. And you don't want to lose a lot of it by reacting with water. So all these reactions are always run under anhydrous without water conditions. Now let's turn the switch on. Now I have it written this way, and a lot of times I'll write it this way. By the way, you can see here my software left justified those hydrogens. Similar to water, the H goes to the oxygen, the OR goes to the one of the carbons in the ring. And switches on for the slide. And you form an ether, alcohol. And that's the reaction. Let's take a look at it. And if I look at the following reaction, the question is, what's the organic product or products are the following? If I look here, what do I have? An alcohol. Look for what's different. I'm reacting, this is different, ethylene oxide. And you break one of the bonds of carbon oxygen in the ring, and you form this ether alcohol. That's an ugly looking R, that's better. And remember, here's the ether. And here's the alcohol, both in the same molecule. And turns out that's very beneficial. And I worked for a company, the one in Gurnee, and this was an important reaction we did on very large batches or amounts of chemicals. This was a product. These type of products are called surfactants, and I'll talk more about surfactants later in the semester. Surfactants is short for surface active agents, and some of these molecules are in your everyday products, such as your hair conditioners, shampoos, and other things. All right, let's let you try one. And why don't you try that one? Give the product or products for the following reaction. And let me scroll it up so in case you didn't memorize it, there's a general reaction top of the screen that will help you. And I'll let you do your work. And when you're done, give me a thumbs up. I see one person done. All right, anybody need more time? I guess not. I better get to work. And if we look at this reaction, what do we have? What's different? Ooh, carbon with a hydroxyl group, that's an alcohol. ethylene oxide, and this is different, three-membered ring with oxygen. And notice I haven't used slang. I'll keep on using ethylene oxide. And what do you get? This ether alcohol. What's my R group? This. Therefore, the carbon with the hydroxyl group is the carbon bonded to that oxygen, which in this case is the center of 3, then I'll CH2, CH2, OH. And there I have my ether alcohol. Oh, let's do another one. These are fun. And here's one more for you to do. Give the organic product or products for following reaction. 3 points each. And don't forget, when you're done, give me a thumbs up. Either use thumbs up with your video cam or use an emoji. Or you can use the other symbols also, emojis in Zoom. Everybody done yet? I think so. Well, wait, I'll give you another. Oh, I haven't used this in a while. All right, I think everybody's done, so I better get to work. If we look at this molecule, the first one, what's different? Carbon, 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 carbon. Oxygen with a hydrogen. Remember, look for what's not carbon or hydrogen atoms or carbon, carbon single bond. This is an alcohol. What do we have here? Ooh, 3 atoms, 2 carbons and oxygen. This is an epoxide, ethylene oxide. What happens? You make as ether alcohol. And what's my R group? 4 carbons. What carbon has the hydroxyl group? Will be the carbon this oxygen is bound to, your ether alcohol. In that case, it's the end one. Do you break carbon-carbon single bonds? No. So I'm going to do 1, 2, 3, 4. I'm going to have my oxygen. Then I'm going to have 2 more carbons. Then I'll have my hydroxyl group. I know there are 4 bonds to carbon, so I can put in my hydrogens. And that's the product you get. Now, one of the things we'll be doing more and more this semester now that we're getting into juicy stuff, the good stuff, fun stuff, is you should ask the question, why am I learning this stuff? Why? Well, the obvious answer is we figured out the first thing is you're not becoming organic chemists, but someone told you had to take organic chemistry to get into a program or into a school, like either dietitian, physician's assistant, or nursing school. But why should you learn this? Let's take a look at what we just made. Now, this molecule, and I'm not going to ask, has a IUPAC name, 2-butoxy ethanol. And this right here is called the butoxy group. And that molecule can be found in a number of places. One place, which is a good place to find it, how many of you have ever cleaned an oven? And there are two types of products. One where you spray or put a chemical into your oven that has been heated. And the other is you use one, the oven is not heated. Get the one that's not heated. And Easy Off Oven, and I don't get any kickbacks from the company I like to, has two products. One for a hot oven and one for a cold oven. The one for the cold oven is safer and works better for you. I've done my own, and I also do my sister's ovens, her oven, she only has one. Anyways, the main ingredient in the cold Easy Off oven cleaner is the molecule you just made, 2-deoxyethanol. How do they make that? Well, just like I showed you, they take 1-butanol, that alcohol, and react it with ethylene oxide. Let's see something. And everybody see on their screen, they have a whole bunch of them now, heavy duty and all these, and they work well. And get the one, see where it says here, warm or cold ovens, get the one with cold oven. That works much better, and it's also safer. Even though when using it in your kitchen, open up the window, and what I usually do is have a fan nearby to blow air through it, or if you have a vent above your oven, turn that on to get the air circulated. Now, everybody see on their screen now, Deepwater Horizon oil spill. You see that now? Thank you, thumbs up person for people. All right, back in April of 2010, wow, 11 years ago. Wow, time flies when you're having fun. Well, anyways, in the Gulf of Mexico, on this oil platform, they had a major failure, and that caused one of the worst oil spills in on our planet's history. And it was pumping oil because the accident ruined their emergency cutoff valves. They couldn't shut it down. And it was many, many days before they could shut it down. Now, in this Wikipedia, they say 210 million gallons. It was a lot more than that. And in the Gulf of Mexico, you were having all this oil being pumped into the water, which is not good. Oil and water don't mix. I'll teach you more about why not later in the semester. Well, one of the things they did was they took a chemical product made by then called, I don't know what it was Nalco in Naperville. That was a dispersant. It was supposed to take the oil and make it into tiny little droplets so it would be safer. And that dispersant was called Corexit. And there are two different versions they were using. Now, Corexit, it's time for me to teach you something that won't be on a test, but you can use the rest of your life. when you have a chemical product that's sold in the United States, every product that's sold in the United States or shipped in the United States has what's known as Material Safety Data Sheet, MSDS. And MSDS sheets tell you hazardous things about the chemical or the product that's being used. Now, in 2010, I was consulting, I was already teaching at ECC. I saw this, and after a day or two, I'm looking at TV, they're talking about how they were pumping millions, yes, millions of pounds of this core exit into Gulf of Mexico. And being the chemist I am, I said, what the heck is in that? And here's what I did. And I was able, they gave the number, and there were two different ones. And can everybody see on the screen that the 9527, the main component was 2-methoxyethanol, the one you just did. And the other one had that 2 at this formulation here. They're showing a different one, but the majority of what they pumped was the 9527. I had never really thought about 2-methoxyethanol. And so what did I do? I went to Google. And after you put a chemical name, you type in MSDS, you'll come up with material safety data sheets from different companies. And you don't know, but I do. Fisher and Aldrich are both reputable companies. Two days later, sometimes Aldrich, it's hard to find it. Let's go back. Let's try the Fisher one. Sometimes when that happens, and here's the MSDS sheet. Now, this will never be on a test, but something that will help you the rest of your life. You can look up how dangerous a chemical is. And generally they have the same parts. There's been some changes, but the higher the number, the more dangerous it is. Flammable, oral toxicity, you see category 4. That's pretty hazardous. If you look at hazardous, combustible, harmful, 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 causes eye irritation. Now, this is a newer one. Back then, they also talked about what damage it would do to people. And here, this is a newer one, but you notice you have the different limits to amounts you can inhale gas-wise. 20 ppm is very small. The newer ones, they don't have as much information as the older ones. Now, this is a newer one because it's been sanitized, but the older one had mutagenic reproductive effects, and it was very nasty stuff. And I read that and I said, wow, this is pretty bad. And in the older MSDS, since the oil spill, they've been changed to make it less dangerous looking, but it said things like will kill fish and smaller fish. And here they're pumping millions of pounds into the Gulf of Mexico. So I was brought up by my parents, thank God for them, that, thank you, but anyways, to be socially responsible. Well, I'm a socially responsible synthetic organic chemist. When I saw that, I wondered, how many people know about this? Why are they pumping it in? So the first thing I did was the Coast Guard was in charge of that. And I got to near the top level and I said, this is dangerous stuff. And they said, oh, no, the ALCO says it's not. It is. Look at the MSDS. And they said, no, it's not. So I realized I was just banging my head against the wall. And being the person I am who doesn't like to give up when there's a problem, as a senior manager in chemical industry, I was well trained by one supervisor. When there's a problem, you know the solution or is a big problem, don't walk away from it. So what did I do? I contacted MSNBC. I contacted CNN. I also contacted the New York Times, and I believe the Washington Post, and let them know this is dangerous stuff. I'm not the only one, I hope, that did that. But within a day or two, the news reporters were asking the EPA, how are you allowing this? And they eventually stopped them from using that, but not until millions of pounds of stuff was pumped into the Gulf of Mexico. Now, a number of years later, I got a call. I don't know how I got in touch, but I was talking to someone. They said, you should talk to this friend of mine because he was a reporter that also helped in the cleanup of the Deepwater Horizon oil spill, because it also fouled the beaches in Louisiana and around the Gulf of Mexico. So a couple of days later, I talked to this reporter and found out something very sad. He actually was also on some of the cleanup boats reporting what they were doing. And years later, this was almost 10 years later, not even 10, that was 2000, say about 2016 or 17, 5-6 years later, he had done an article that I think that's where I got in contact or found out about him. But anyways, where what I had told the Coast Guard that was in the MSDS, people who worked on the cleanup boat and cleaned up were now having those type of health problems. Also, it destroyed for many years the fishing in the Gulf of Mexico, which was sad and hurt the livelihood of many, many fishermen down there. And the thing is, you now know how to make it. There are good things that can come from chemicals. If they're not used properly and you don't know the hazards, bad things. And that's just the way things are. I went a little over. Let's take a 5-minute break. Why don't you come back at 2 o'clock? You're going to get out early. It's a quick lab. I'll see you in 5. Oh, let's get fancy. Time to get going. All right, welcome back, everybody. Now, for this lab, sad lab because it'd be more fun if we were in ECC, but we're not. But let's make the best of it. This is a fun, quick lab that I threw in the schedule to just have a quick lab. And if we were face to face now, I would talk about 10, 15 minutes, which is what I'm going to do now. Then you go in the lab and you'd be done in about 10, 15 minutes. And you're going to get out early today. Thank you, Dr. White. You're welcome. What's today's lab? It's aromatic compounds. And why are they called aromatic? Because they smell. They have very strong odors. Now, thumbs up, people. Everybody see on the screen aromatic compounds? Thank you. All right. Now, aromatic compounds, as it says on the screen, play an important role in our life. And they come from spices and herbs. Now, throughout the 1400s to 1700s, wars were fought to control the spices, which were quite lucrative to sell them and control them, and the lands where they were grown, so you could control them. And this involved many of the nations in Europe that fought wars to control that. Now, all these spices have a common feature. They're aromatic because they have a benzene ring in them. And some of the molecules include eugenol, isogenol, vanillin, benzaldehyde, and trans-cinnamon aldehyde. Now, in this lab, you'll be using a very sensitive analytical instrument, your nose. Now, if we were in face-to-face, I'd ask you to smell these, and you'd write down your observations. And what will you be smelling? You would be smelling cinnamon, cloves, nutmeg, vanilla, and benzaldehyde. Now, unfortunately, I can't say, here, go smell this. Hopefully you have, for some of those, access to smell. Now, one of the more interesting things, I'll talk more about this later in the semester, one of the most difficult problems I had to solve as a research manager for one company I worked for dealt with odor. And that problem, if I hadn't solved it, there was about $30, $40 million riding on it. And odor problems, how you smell things, is very complex problem. Later, when we get into what's called quaternary ammonium salts, I'll tell you the whole story. It's quite an interesting story dealing with Procter and Gamble. That I worked for a company that sold a product that they used in their product. But anyways, each one of you have different life experiences. When you smell something, you perceive it differently than other people. And let's talk about some of the things you'll be smelling. Now, in this lab, you would take some of it, if it's a liquid, you'd put it on a piece of paper that Dr. Daly, who's our lab manager, I used to have students rip their own from paper towels. No, he went and had 2x2-inch squares. And what you do if it was a liquid, you'd put it on there. If it was a solid, you could smell it right from the bottle. Now, let me teach you. When you smell something, let's assume this is a bottle of chemical, use your imagination. Never put your nose over a bottle. That could knock you out and do serious harm, because some odors will do serious harm. You always go like this to take a small amount to your nose. That's a safe way. One company I worked for, Axo, they made a series of products that were quite strong, sometimes had ammonia in them. And if you've ever smelled ammonia, it's strong. And to train new R&D chemists not to put your nose in a bottle, they would have someone would give them a bottle of this product, say, why don't you smell it? And whenever that happened, we'd always have a couple people standing behind them, because sometimes it would knock you right off your feet. Well, when I joined that company, I'd already worked one summer at a company that worked with ammonia and nitrogen compounds, which is what Axo made. I knew how bad they were to smell. So they gave it to me. And I said, oh, and I went like this, and they all started booing because they wanted to see if I'd get knocked off my feet. And I said, no, I know better. But anyways, if you have these compounds at home, please take a try and smell them. And there's no right or wrong answer, but if you have cinnamon, nutmeg, or vanilla, write down. If you don't have something, don't worry about it. Now, cloves you might not have, and students have told me cloves remind them of Christmas ham. And the other thing is, it reminds me of a dentist office. Dentist office? Well, oil of cloves, which is eugenol, that's a chemical. If you've ever had dental work done, and unfortunately, in my family, it's hereditary, not good teeth and problems. And I've had it, my sisters have had it, we inherited it from my father. Anyways, unfortunately, we didn't inherit his good hearing. We got that from my mother, her bad hearing problem. But anyways, if you ever go to a dentist and they're going to inject you to anesthetize something in your mouth before they go drilling or doing a root canal, I've had anyways, if it's a good dentist, they'll rub some liquid on there to numb your gum before they inject you. And what's that liquid? Oil of cloves. And that's why whenever I smell that, I think of the dentist's office because I had a good dentist. They do that. You smell cloves, and I think dentist office. And certain, obviously now you know, certain molecules from herbs and spices have medicinal properties, and that's one of them. Now, another one, which is fun to do in the class, is benzaldehyde. And that's the IUPAC name of, I'll teach you later on when we get into aldehydes. And benzaldehyde is an interesting compound. What makes it interesting is when you smell it, and I put it up here, it either smells like cherries or almonds. And what are some of the cherries I smell? When I smell benzaldehyde, maraschino cherries. Those are the ones that come on top of sundaes that glow in the dark. And also, I'm a Dr. Pepper person, when I smell Dr. Pepper, I think of benzaldehyde. Now, at the same time, when I smell benzaldehyde, I think of almonds because it's also a key ingredient in the odor and taste of almonds. And for those who you know about pastries and other delicacies made with almond paste that's been sweetened, it's called mascarpone. And that I've had in Europe, different desserts with mascarpone. You don't see it that much in the United States, you gotta look for it. But anyways, when I smell benzaldehyde, I can think and say, I smell cherries, and at the same time, I can smell it again. No, I smell almonds. You smell both, at least I do. So if you have a chance, if you have these, go and smell them, put down what you think. Now I've got some questions here. Now, one of the things to help you out, I would like you to draw the structure of the key aromatic compound or chemical found in each spice. Now, I've helped you out. In cloves, it's eugenol. In cinnamon, I love cinnamon. My older sister hates it with a passion. Is tranexamic acid. Actually, that should be aldehyde. That should be. I'll correct it and I'll change it sometime today or tomorrow. Today, I will. And then nutmeg is isoeugenol. Vanilla extract, the chemical main ingredient, is vanillin, and benzaldehyde. You can use Google. Notice generation gap. I don't use Google as a verb. I use it as a noun. But anyways, ooh, we're getting English in chemistry. But anyways, draw the structures and don't forget to answer question number 3. Like I said, this is a fast lab. I'm done. That's the lab. Don't forget the lab we did on last Wednesday is due today, sometime today. And with that, I will remind you my office hours on tonight and Wednesday from 6 to 7:15. Speaking about office hours, last semester and the semester before, that worked fine, the one I have now. If you think of a better time for my office hours, let me know and maybe I'll change it, be able to change it. But I should tell you, on Monday through Thursday, from 9 till 4, I'm teaching, both at COD, College of DePage, and here. Now, on Friday, Saturday, and Sunday, I like that for myself. So if you can think of a better time on Monday through Thursday, either before 9 o'clock or after 4, that you'd like my office hours, not too late either. No, I'm not going to do it at midnight. No, thank you. Let me know. And with that, I'll stick around if you have a last minute question. If not, gehen gesund. Remember, that's Yiddish for be healthy. And I'm done. Bye now.